Let's use the triangle below to prove the sine law. Sine A over A equals sine B over B, which equals sine C over C. By convention, the capital letters represent the angles, where the lowercase letters represent a side length. We have A here, and we have capital A here across the field. Focusing on the right triangle, we see that sine B is opposite over hypotenuse, h over A. Multiplying both sides by A, we get h equals A times sine B. So we have h. Now let's focus on the left triangle. We have this right triangle here. Sine A equals opposite over hypotenuse, h over B. Multiplying both sides by B, we get h equals B times sine A. We also have h here. We know that h is this as well as h is this, so therefore we can equate these two things together. A sine B equals B sine A. We have this equation, and now we're going to divide both sides by A. So dividing by A, we can see that these a's cancel out. We get sine B equals B sine A, and of course we have to divide both sides by A, all over A. Now we divide both sides by B, divide by B, and when we divide the right hand side by B, the B cancels out. So sine B over B equals sine A over A, and this is what we're trying to prove. Now because we dropped a perpendicular line between AB, we were able to prove that sine B over B equals sine A over A. Similarly, if we drop the perpendicular line this way, perhaps you can redraw this triangle, you can also prove that sine A over A equals sine C over C. You can try that yourself. Now, given the previous proof, why does it follow that A over sine A equals B over sine B equals C over sine C? We're just taking the reciprocal of both sides of an equal sign. It's just algebra. As a rule of thumb, it's good to use this equation when the unknown side we're trying to solve for is on the numerator.